Imagine telling an AI, "Open my browser, find the monthly sales report, and download it." A normal chatbot might explain how you can do this, but computer use AI is designed to actually interact with the computer. It can look at the screen, understand what is displayed, decide what action to take, move the mouse, type on the keyboard, click buttons, and then look at the new screen. So how does this actually work? In this video, we'll break the entire process down step by step. Computer use AI is essentially AI that can interact with a computer through its user interface. Think about the difference between a traditional chatbot and a computer use system. With a traditional chatbot, the flow is you give it text, the AI processes the text, and the AI gives you text back. But computer use AI adds another layer. You give the AI a goal. The AI looks at the computer screen. It understands the interface. It decides what action to take, and then it actually interacts with the computer. So instead of only generating an answer, the AI can perform actions inside a digital environment. The easiest way to understand computer use AI is through one simple loop. See, understand, plan, act, check, and repeat. First, the AI observes the current state of the computer. Then it tries to understand what it is seeing. Next, it decides what action should happen. It performs that action using something like a mouse or keyboard interaction. Then the computer changes. The AI observes the new state, and the process starts again. This feedback loop is one of the most important concepts behind computer use AI. Let's start with the first step, seeing the screen. Imagine your computer currently has a browser open. You might immediately recognize the search box, buttons, menus, text, and icons. But an AI system needs to process the visual information available on the screen. The screen can be represented as an image or other structured UI information. The AI then needs to identify the important parts of that interface. For example, where is the search box? Where is the login button? What text is visible? Which elements can be clicked? Which parts of the screen are relevant to the task? This is the beginning of computer interaction. But simply seeing pixels isn't enough. The AI needs to understand what those pixels represent. For example, suppose the screen contains a rectangular area with the word search. A human immediately understands this is a search box. The AI needs to reach a similar understanding. It needs to connect visual information with meaning. So conceptually, we can think about the process like this. Pixels become visual features. Visual features become UI elements, and UI elements become meaningful objects that the AI can reason about. This could include buttons, text fields, menus, links, checkboxes, images, and other interface components. Now let's say the user tells the AI, "Find the monthly sales report and download it." That's not one simple computer action. It's a goal containing multiple smaller tasks. The AI needs to figure out what needs to happen. Maybe it needs to open a file manager. Maybe it needs to navigate to a folder. Maybe it needs to search for a particular file. Maybe there are several reports, so it needs to identify the correct one. And finally, it needs to download or open the file. So the AI transforms the natural language instruction into a sequence of possible subtasks. This is where reasoning and planning become important. Once the AI understands a goal, it needs to decide what to do next. For example, imagine the user says, "Search for the monthly sales report." The AI might determine that the next action should be, click the search box, then type, "monthly sales report." Then press enter. Then observe the search results. Notice something important here. The AI isn't necessarily planning the entire interaction once and blindly executing everything. Because the computer can change after every action, the AI can make a decision, perform the action, observe the result, and then decide what comes next. That makes the system much more adaptive than a simple fixed sequence. Now the AI needs to actually interact with the computer. Suppose it decides that the search box needs to be clicked. The system can generate an action such as, click this location, then another action, type the requested text, and then press enter. Conceptually, the flow looks like AI decision, mouse or keyboard action, computer responds, new screen appears, and the AI observes the result. This is the point where AI reasoning connects to actual computer control. But there is a major problem. What if the action doesn't produce the expected result? For example, the AI clicks what it believes is the search button, but maybe the website changed. Maybe the button moved. Maybe a pop-up appeared. Maybe the click didn't register. A simple automation script might fail at this point, but a computer use AI system can potentially observe the new screen and determine what happened. It asks, did my action work? Is the expected element present? Did something unexpected appear? What should I do now? This is why observation after an action is so important. Now we can see the complete process. The AI sees the screen. It understands the current state. It plans an action. It performs the action. The computer changes. The AI sees the new state. Then it decides what to do next. So the process becomes observe, reason, act, observe again. And this cycle can continue until the task is completed. This is fundamentally different from simply generating a text response. The AI is continuously interacting with an environment. Let's take a simple example. Suppose the AI expects a download report button to be in one location, but the website has changed. The button is somewhere else. The AI attempts an action based on its understanding. The result doesn't match what it expected. Now the AI has a new screen state. Instead of necessarily continuing blindly, it can analyze the new state again. It may identify the button in its new location. Then it can adjust its plan. So the loop becomes wrong prediction, new observation, replan, correct action. This ability to react to changing conditions is a major part of computer use AI. Let's compare this with a normal chatbot. Imagine asking a chatbot, how do I download this report? The chatbot might tell you, open the website, find the report, click download. That's useful, but you're still doing the actions. With computer use AI, the instruction could be, download this report. The AI can potentially navigate the interface and perform those actions itself. So the difference is not simply intelligence. It's also the ability to connect the AI's reasoning to actions in a computer environment. So what does the architecture look like? We can simplify it into several layers. First is the user instruction. For example, download the sales report. Next is the AI model. The model interprets the goal. Then comes screen or interface understanding. The system determines what is currently visible and what elements are relevant. Next comes action planning. The AI decides what should happen next. Then computer control executes the action. Maybe that's a mouse click. Maybe it's typing text. Maybe it's pressing a keyboard key. After the action, the computer changes. The new state is observed, and that information goes back into the loop. Then the AI decides the next action. So the architecture is not simply input, AI output. It's closer to goal, observe, reason, act, observe, reason, act. Let's use a simple example. Suppose you tell the AI, find a flight from Mumbai to Delhi tomorrow. The AI first needs to understand the goal. Then it may open a travel website. It needs to identify the departure field. Enter Mumbai. Identify the destination field. Enter Delhi. Find the date selector. Choose the correct date. Then click search. But that's not the end. After clicking search, the page changes. Now the AI needs to observe the results. It might need to identify available flights, times, prices, and other information. So again, observe, understand, act, observe, repeat. This is the basic interaction pattern. At this point, you might ask, isn't this just traditional automation? There is an important difference. Traditional automation often depends on predefined instructions. For example, click here, type this, click there, then click another button. If the interface changes significantly, the automation may fail. Computer use AI tries to make the process more adaptive. Instead of only following fixed coordinates, it can potentially understand the current interface and decide what action makes sense based on what it sees. So traditional automation is often follow predefined steps. Computer use AI is closer to understand the current state and decide the next step. This technology could be useful for many computer-based tasks. For example, web browsing, data entry, software testing, research, form filling, file management. customer support workflows, business operations, and repetitive desktop tasks. The common requirement is that the task can be performed through a digital interface. Instead of writing a separate automation workflow for every small variation, computer use AI aims to make interaction more flexible. But computer use AI is not perfect. There are several major challenges. First is visual understanding. Modern websites and applications can be complicated. Second is accuracy. One incorrect click can lead to the wrong result. Third is reliability. Long tasks may require many individual actions, and errors can accumulate. And fourth is safety. Imagine an AI that can access your email, banking website, or business systems. You don't want the AI to perform an important action just because it misunderstood something. That's why permissions, monitoring, confirmation steps, and human oversight are extremely important. A practical approach is not necessarily AI does everything. Instead, it can be human gives the goal. AI performs routine computer interaction. And when something important happens, the human can approve the action. For example, reading information might happen automatically, but sending an important email, making a purchase, deleting data, or changing critical settings could require human confirmation. This creates a model where AI handles repetitive interaction while humans remain responsible for important decisions. So let's put everything together. Computer use AI starts with a goal from the user. The AI interprets that goal. It observes the computer interface. It identifies useful elements. It plans an action. It controls the mouse or keyboard. The computer responds. The AI observes the new state. If everything looks correct, it continues. If something unexpected happens, it can potentially adjust its plan. And this loop continues until the task is completed or the system needs human intervention. So the complete process is see, understand, plan, act, check, and repeat. If you remember only one thing from this video, remember this. Computer use AI is not simply an AI that generates text. It is an AI system that connects understanding and reasoning with interaction. It observes a computer, understands what is happening, chooses an action, performs that action, checks the result, and then decides what to do next. In one simple line, see, understand, plan, act, check, repeat. And that's the basic idea behind how computer use AI actually works.